Hello, Algebra 1 students. This is going to be the last lesson in our simple linear equations and inequalities unit. And it's going to be a little bit different than the others in terms of its theme. We're not looking for some concrete answer or bigger than 3 or no solutions or something like that. We're just trying to manipulate an equation purely to change it into some other form of itself. Okay? So it's all about solving for a variable, and some problems will then ask you to like plug something in and find an answer, but most of them are just going to ask you to purely solve and rearrange the equation. Okay? So for instance, most of the equations in here as well are things you should really start thinking about, like in Algebra 2 as well. There's all kinds of good science in these problems, and I'll be telling you a lot about that science. You need to know that later on, and if you just like totally zone out on all of it, you'll be at a big disadvantage to the people who really cared, and there are many of those people, so you've got to be careful, okay? So a lot of these are real physical formulas for something, and I'll talk about those as we go. So let's have a look at our first one. So this, can anybody tell me what this formula might be? It's actually a real formula. What might F and C represent here? It goes with a theme we discussed at length the other day when we talked about absolute zero.
Freezing and cold.
Good idea, no. Fahrenheit and Celsius, very nice. This is actually the formula to convert from a Celsius temperature into a Fahrenheit temperature. And you can see that it's basically just mx plus b, right? So that's a little bit of science background. There's of course a likewise formula to take a Fahrenheit number and change it into a Celsius number, and that's our goal here. Now you don't have to know all that science to do these problems, but hopefully you're like trying to be alive when you're doing your assignments and trying to learn stuff, because there's a lot of stuff to be learned if you actually try. Okay? Don't just go through the motions, or you'll be the poor student instead of the superior one. Okay? So we're trying to solve for C in this case. So we need to move stuff away from C just like we've been doing. Any suggestions?
Subtract 32.
Yep. We usually subtract stuff first, right? And that's not going to combine with F. It's not a like term. So it'll just have to chill on its own. F minus 32. And what's left then is 9/5 C. How about my next step? I need to move the 9/5, right? So there's lots of ways to do that. The way I've been recommending you do it is what? Times 5 first, right? Is to kind of like rewrite this as 9c over 5, or at least just think about that in your head. You can totally skip that step if you want, as long as you're comfortable that this is the same thing. And say, okay, just like Jack said, times 5 times 5. And that will cancel this 5. Now, on your first quiz, a lot of you did really pretty good on the problem with the fraction in it, but you mostly all made the same mistake, and it was just like right here. This is what you guys would have put on your first quiz. You'd have put basically 5f minus 32 equals 9c at this point. Now, I've made a mistake when I do that. What's my mistake?
I don't know if I'm saying this right, but you're combining the number with the variable, which you can't do.
I see what you're saying, but I can do it. I can combine that. Like, that's fine. Good idea, though, Lily. I like it a lot. Good suggestion. It's not quite it. What did I do wrong?
Did you really distribute the 5 to the F?
Yes, very nice. So really, when I did this, since the other side had more terms than just one, it had 2 terms, I really needed to put parentheses there, or I didn't really multiply the 5 to the other side. I just multiplied the 5 to one piece of the other side, and that's illegal. Does that kind of make sense? That would create an imbalance. So instead of 32, I need to have, you could use your calculator, right? 5 times 30 is 150, and 5 times 2 is 10, and 10 and 150 is 160, and it's negative. And now I have one step left. C is almost by itself. I just need to divide by 9. So I'm going to go divide by 9, and I'm going to do it to the whole other side. That's kind of easier to not make a mistake there, but it's the same concept of doing this 9 to the whole other side as when I did the 5 to the whole other side. That was a little sneakier than doing it here, I think, but it's the same thing. Okay, so since I'm running out of space, I'm going to go back and erase this step and write down my final answer. So my final answer is 5f minus 160 divided by 9 equals C. And if I wanted to, I could split up that common denominator and write it as 5f over 9 minus 160 over 9, and even try to reduce those. You can or you cannot do that. That's a judgment call that you're going to make yourself, okay? This or this are both the right answer. I don't care which one you give me. Hopefully you can decide that they're both correct. Okay, and now someone could give us a Fahrenheit, like some of your problems will, like 10 degrees, and say, how much is that in Celsius? You could just put 10 right here and plug this whole thing into your calculator, and it would tell you what the temperature was in Celsius. Okay, we'll do a problem like that before we quit, just for one example. There's our first one. Number 2. I don't believe we have any sophomores in here. If we did, some of you'd be in chemistry and you'd recognize this formula because it's ultra, ultra important. This is the ideal gas law, which describes how the pressure, volume, and temperature and number of moles of a gas relate to one another. So a very important one, and I know it's in your assignment a couple times. So we're going to be solving for n here, which coincidentally represents the number of moles. So if I want to get that n by itself, how am I going to do that? I heard divide. I like it. Divide by what?
RT.
Yeah, you got it. So you're very good at this, Jack. You have a natural affinity for it. If you do some more practice, you'll be spectacularly good. I promise you that. That cancels it out though, right? So I think I'm done. One step here. And a lot of your problems will be like that. So if you want to solve for the number of moles of a gas, you end up multiplying the pressure times the volume. This is just some number I'm not going to talk about now. And you divide by the temperature. I think we're done there. Okay? Anyway, so there we go. Let's look at number 3 down here. I'm going to erase this one. So number 3, I don't think this one has a specific meaning. I just tried to simulate some of the problems you're going to be working with, so no actual meaning here. I made it up. So we've got an expression. It's got all kinds of variables, h, k, z, l, g, whatever. Key is they want us to solve for which one? L. So you go, okay, where's L? It's down there. So, any suggestions on this one? This one's a little bit different, I think. The L's in a weird place, and that's what we want, right? So you should be like, well, I don't like it down there.
Multiply.
Multiply by?
L.
Yes, that's right. So this is kind of a little bit different because you're not like trying to move something away from L right away. L is in an inconvenient location, and you're trying to make it move to somewhere that's easier to understand. Does that kind of make sense? So you should have that gut of like multiplying like this, just like Nate did, though. I think that's pretty good. So if you do it to one side, you do it to the other side. So over here, it's going to cancel out, right? And what will be left is, you guys tell me, h minus k, 2z
equals g 4 L.
Is that right?
No, because wouldn't you have to multiply L times 6G?
Yes, we would. This L is right on. That L has to hit the whole other side, so I also need an L right in here. Like that. Whether I call it GL or LG doesn't matter. But it's got to hit both terms. It's distributed, right? Okay, so now we need to get L by itself. So what's the problem with that?
There's 2 variables.
Yeah.
It's in 2 spots. Yeah, exactly. So this is the first time this year we're going to factor. Factoring is going to be a big, big thing. This is the first time this year we need to have it happen because these don't look like terms, and in fact they're really not completely like terms because that one has a G, right? So the idea is, well, they both share an L, so what we're going to do is say they share that L, and we'll pull it out and see what's left. So 6 G's left here, and what's left there when I pull the L out?
4.
Just 4. And then we still have our other stuff over here. We didn't do anything to that side yet. So this is the first time we've had to factor this year. Now, I would argue with you guys that we could have avoided it if we really understood what we were doing. Why? Does anybody see why we could have avoided doing that and thinking like that? Why?
I don't know. My first thought was to just put parentheses around 6G and plus 4 and put the L in front of it.
Mhm.
I don't know, that's just what I thought.
And put the L like over here?
Yeah.
In fact, look at this and look at this.
Same thing.
Aren't they the same thing? Does it really matter what side the L's on? Not at all. So even though you guys had the really good instinct to distribute, that's a great instinct. But it didn't help us here. We had to undo it. Factoring undoes distributing. And that's really an important thing, so I'm glad we had the opportunity to discuss it for a first time. But we could have just gone, never done any of that at all, and said, what are we really trying to do here? Get what by itself? L. What's in the way? This whole piece, this whole quantity is in the way. And what's it doing to L? It's not adding, it's not subtracting, it's multiplying. So you divide by that whole piece on both sides. Do it on one side, you do it on the other side. I've kind of gotten pretty sloppy here, so I'll definitely write down what I have left. Because remember, these canceled out. Yeah, I've gotten really sloppy, but there you go. So it's h minus k plus 2z divided by the quantity 6g plus 4 equals L. Okay? So that one could have been really easy if you chose the right path. If you didn't choose the right path, you had to end up factoring. I'm glad we had a discussion about factoring, though, because you might run into a question or two in this assignment where you don't see that right away, and you might have to factor as well. Just depends on how you go about thinking. Okay? Let's look at a couple more. So number 4 over here. This one does have a very important physical meaning. Anybody know? Should have learned this one in middle school. But people have been coming from middle school not knowing this for a while now, for a few years. Have you seen it before? Okay, we have seen it before. Good. Sometimes this is called KE instead of K. KE stands for what? Yes, okay, good. Kinetic energy. Kinetic energy is half. What does M stand for here? Mass.
Mass, yes.
And what is V?
Volume.
Velocity. Usually volume's a capital V, like in that other one that we just erased. So this is the kinetic energy of something that's moving with a certain velocity, okay? And I don't want the kinetic energy, I don't want the mass. This one asked me to solve for the velocity. They could have asked me to solve for the mass. The key of this section is you should be able to solve for whatever they ask, right? So you just move stuff. So I am going to rewrite this one first, because I think that makes it easier, as mv squared, and where am I going to put that 2? Underneath, because that's what half really means. Doesn't it mean divide by 2? So remember, you can always rewrite fractions this way. It makes it a lot easier to think, because now the first step to get v by itself is to multiply by 2. This time we don't have to worry about distributing or anything like that. Just got 2 kinetic energies. Now we want v by itself, so what's next? Divide by m. So then we have 2k over m equals v squared. And now you guys haven't done this operation yet because we've been solving linear equations, and this one technically is not a linear equation, it's a parabolic equation, which we'll be spending multiple months on next semester. Does anybody know how to remove squared?
Divide.
It's a different operation. It's not add, subtract, multiply, or divide. Square root gets rid of squared, just like multiply gets rid of divide. If you do it one side, you do it to the other, okay? So that cancels out, and what we're left with there is v. And over here we have the square root of 2k, kinetic energy, over mass. And I would just like, as you're doing these problems, see if you could recognize one of these, or at least guess, what do I think h means here? And you're not going to know in all of them, but a few of them, hopefully you'll be thinking about your science, okay? Technically also, we'll learn this when we get to parabolas. When you use a square root to solve an equation, there's a side effect, just like a drug side effect. And that side effect is you have to use a plus or minus. There's actually 2 answers then. So I wouldn't want to teach you wrong math, even though it's going to be a while until we use that. Okay? So square root has a little special thing. That thing is plus or minus. All right. So the last one we're going to look at, I'm going to put it over here in the center, is this guy. A little bit more interesting. This is a guy, or pretty similar to a real thing. I made it a little bit, changed just a little bit from a real thing, so it's a little bit fake. but it's almost a real thing from what we've been doing in my physics class recently. So this one describes how things spin, and this Greek letter omega here and this Greek letter alpha here talk about their angular velocity and their angular acceleration as they really speed up. So all we would need to do is think about what we want to solve for. So I asked 2 questions this time. I said, first, let's solve for that thing. That thing is omega sub 0 squared. And then we'll solve for something else. So some problems will ask you to do this. They'll ask you to solve for 2 different things. Just do 2 separate problems, okay? So we want this by itself. What do I do first? You guys tell me. Key is not to be intimidated by these and just be like, oh, I just have to move that stuff. What stuff do I need to move first? That stuff. All of that stuff. Isn't it all separate from what we want? It's doing what to what we want? Adding. So subtract it. You subtract it on one side, you subtract it on the other side. So I hope you guys can see that this assignment's a little bit more exotic. If you don't practice it, you're not going to learn any of it.
Yeah.
So make sure you do. This was one of their favorite topics on the SAT last year, and it will continue to be so for the next several years. And it's an easy topic, so you just have to do your practice and then be thankful because it's easy. But anyway, these are totally different things, right? So there's no way they're like terms. You can look at them and go, man, those are different things. And so you guys tell me, are we done? Or do we need to take a square root on this one?
No, because you were solving for that.
Yeah, it said to solve for that squared, not for omega sub 0 without the squared. So we're done. That's the first answer they were looking for. Now we could plug numbers into it if they asked us to. They also asked us to do the same thing, take the same equation, I should say, and solve it for time. So we're going to go back and rewrite it. Make sure you do that. Don't try to start from here or something. Just go back to the beginning and say, now I'm going to solve for t instead. So, t, be right there. What do I need to move first this time? Ooh, you had an idea. That's nice. You want to multiply by t first? That'd be an option. We could do that. What will be another option? I think I want to do something else. It'll make it a little easier. Good idea, though. Great idea. Yeah.
What was the word for the Greek letter?
Omega. Yeah, if you guys want to learn a little bit of Greek letters, that's very, very, very useful. This is a more exotic one. It's called omega.
Okay, so you would subtract that from...
Yeah. You guys hear her? She's saying subtract this thing because t's there, so move him. Go like this on both sides. And now these almost look like terms, don't they? But they're not totally the same because this one has a special subscript. So if you put those together, though, I wouldn't blame you at this point. I'd be like, yeah, you guys know what you're doing. So now I want to get t by itself, and now I think we're going to have to do what Ella said. It's down there. I don't want it down there. Down there's bad. I need it on top. So I'm going to say, right, it's divided, so I'll multiply. Somebody tell me what I should add with my multiplication.
A square root.
Like this is going to cancel it out here, right? It's going away. What do I need to put over here to make this legal?
Oh.
T. No.
Yeah.
Yeah.
I either have to distribute it in my head or write it out on the next step, but you should put the parentheses there. That's the habit you need. Okay? So let's see what we have left. I'm just going to rewrite it one more time. I know sometimes my omegas look like W's. Sometimes my alphas look like fish. That's the way it goes. I think we only have one more step if we want time, if we want t.
Divide
T is multiplied by that stuff, so
Divide.
divide by that stuff, right? It doesn't matter how ugly the stuff is. If all the stuff is multiplied by t and that's what you want, it could be the ugliest thing in the world and you're like, I don't care. I'm just going to divide it on both sides and I'll be in good shape because it's just going to cancel out the whole stuff. So what's left is time, or t, and our answer is going to be 2 times alpha over this stuff. There it's solved for t, there it's solved for omega sub 0 squared. So I think a big part of this is just, moving stuff just like you've always known how to do, and not getting intimidated, not getting psyched out by weird variables that you've never seen before in some case. Just move them. That's all you got to do. Okay? I'll see you next time.